All right. Oh, let me erase. This was my geometry video. Some of you guys are like, I don't want to go into geometry now. Let me just say too at the beginning here while I'm erasing a little background work here. Pay no attention to the man behind the curtain. But basically, I want to say right now, I miss you guys. I know it's rough kind of doing online, but hopefully, we're plugging through. And I miss being at the school. I know you guys do too, but we can still kind of making our math way here. I want to introduce our next thing to look at. Really, all these things kind of tie together now. It's hard to say this is a totally different unit, especially in pre-algebra, because it all kind of ties together. And so this is going to go with the substitution that we just did, because I kept the substitution pretty basic, because now we need to look at what our order of that we do problems, because that now the problems are going to get bigger and we need to know the order to do them. So this is called order of operations, and all that means is, okay, an operation, we talked about this in math lab, an operation is either addition, subtraction, multiplication, or division. It's those basic math operations you do. You add something together, you subtract something. Well, there's an order to it. There's a way you have to go in order. And I'm going to put the acronym that we use. Acronym is just a fancy word to represent another word. It just means like CIA is an acronym, or FBI, or it's a letter, letters representing, words. And so what we use, and this, if you look it up online, there's several different ones. The one that we use here at the school is called PEMDAS. And I've actually taught it as PEMA. There's some that also call it GMA with a G, and I'll kind of highlight that. But basically, we use it as this. There's just one key element that I want to make sure, if we use this way of doing it, PEMDAS, that we keep one key fact definitely in order to make this work. But what this stands for is parentheses. And I'm going to write this in a special way. Exponents, if I can spell correctly. Multiplication, that's the M. And then I'm going to put underneath it division, and I'll explain why here in a second. Addition, and subtraction. Okay, now the reason why I put the two underneath here, and that's the main reason why I used to teach this as a PEMA, and it doesn't, however the acronym you use is fine, but this is the order we go in, okay, PEMDAS, but parentheses always comes first. That's the first thing you're going to do. Something inside of parentheses, you're going to do the parentheses. That's what that's meaning. Work with your parentheses first. Then you'll do your exponents. Okay, you do those next. The thing about multiplication and division is it's actually a tie. Okay, and that's very, very important, because when you're going left to right, okay, which is what, we read left to right in English culture. We read left to right, so we think we do our problems left to right, but that's not always the case in math. Math is its own language, and so it's not always the case. There's other languages that read right to left. Hebrew, I think, reads right to left. I think even some Chinese languages read right to left. So it's, we kind of are used to going left to right, but it's not always the case. And in math, you're not always going to be going left to right. But if it gets down to a multiplication and division problem, then they're a tie. You're just going left to right at that point. Same thing with an addition and subtraction. Now, I know that doesn't mean a lot, but when we get into it, I'll really try to show the difference here. Let me put a problem up on the board real quick and show why we even use all of this. Okay? 8 minus 2 times 3. And I use the little dot for times here. 8 minus 2 times 3. Okay? If we're just going left to right and you're answering it and you're like, well, I'm just going to go in order that I think, just go left to right. Okay, and this answer is going to be wrong. So if you're putting notes, make sure you know this is going to be a wrong answer. But 8 minus 2 is 6. and 6 times 3 is 18. Okay, but that's not the correct answer. Okay, if we just went left to right, we would think, oh, it's 18. 8 minus 2 is 6 times 3 is 18. But if we follow the order of operation, what we're supposed to do is we would actually do the multiplication before we would do the subtraction. Now that's where I want to show that this, whether it's multiplication, division, will go before addition or subtraction. These are the two that ties this, but it's all before addition and subtraction. So that means I do 2 times 3 before I would do 8 minus 2. And so I would do, if I was doing this problem in order and kind of going down, I would do 8 minus 6. That's 2 times 3. And then all I have left is 8 minus 6. So I get 2. Okay? And that's much different than 18. I try to put this in a real world scenario, even though this would be a silly real world scenario. But let's say I was trying to figure out, I had a couple classes, and let's say I had 8 candy bars. And I had these 8 candy bars. Now this is going to be silly, but it shows where it really could make a difference, especially as the problems get bigger. But let's say I had 8 candy bars, and all I knew about my classes was I had 3 students in each. And I needed to know, do I have enough candy bars? And so I had these 2 classes, and I had 3 students in each. And I know, like I said, we could do this in our head and not even use algebra, but this is what builds into algebra, that these problems are set up in a way that we've got to do them in order. But let's say I said, okay, I had these 2 classes of 3, and even if I wrote it like that, or took it and wrote it like this, meaning each of my 2 classes had 3 students, would I have enough candy bars? So if I was trying to do this problem and I went like this and say, okay, I started with 8 candy bars, subtracted 2 times 3, that means I'm left with 18 candy bars. Somehow I gave out candy bars and ended out with more than I started with. That shows that this could go awry. If we just go left to right, it could be really off. But if I figured out, oh, well, 2 times 3 first, so 3 students in 2 of my classes, that means I had a total of 6 students, and I had 8 candy bars, and I took those 6 candy bars to give to the 6 students. That means I'd have 2 candy bars left. I'd have enough, but I'd be left with 2. So that kind of shows where the order of operations, especially when you get into these big problems, really does matter. And you have to use this order to do it, okay, so that it fits into the math language. Okay, now I want to break down, let me put one up here that shows that these being a tie, okay? So let me put this problem up here. Okay, now I look at a problem, I got 8 divided by 2 times 3 plus 7 minus 3. And so I need to go through the order of operations and see which ones do I do first. Well, there is no parentheses. There's no parentheses in this problem, so I move on. There's no exponents, so I move on. Now there is multiplication and division, and this is where I put these up and down, because if I put them side by side, multiplication and then division, you would think I need to do this first, multiplication before division, and that's not the case. In fact, if you were to do that, you'd be stuck having to do 8 divided by 6, which doesn't come out even in this problem. And it makes it harder, because you got to do fractions, and it's not going to be correct in this case. When it gets down to multiplication and division, and that's all you have left, besides the additions, those will come later, but when you're trying to decide which one to do first, they're a tie. And so you do the first one left to right, meaning if it was multiplication first, then you do it first. If it's division in this case, then you do it first, okay? So when it's down to this, they're a tie. So that means I'm going to do 8 divided by 2, which is 4. I still have my times 3, plus 7 minus 3. And I would suggest doing these problems one step at a time until you get the hang of it. So I did this step first, division. Now all I have left is multiplication, addition, and subtraction. Well, multiplication still comes before addition and subtraction. So I'm going to do it next, 12. Okay. And now all I have left is an addition and subtraction. Those two are a tie. So I just go left to right at this point. 12 plus 7 is 19. 19 minus 3 is 16. Okay? So my answer to this problem is 16. I would go back through, try that, see that, kind of go through. Let's do another one like that. Okay? Okay? So just so you see the symbols right, 6 divided by 3 times 4 minus 2 plus 8 times 2. Okay? We're not just going to go left to right. That would come out wrong. We're going to follow our order. There is no parenthesis. We're going to do some parentheses here in a second, but there's no parentheses, no exponents, so we're down to here. There is multiplication and division in the problem, but I'm just going to do left to right because they're a tie, and I'm going to do all the multiplication and division ones. I'm not going to do the addition and subtraction yet. These need to be done before these, and I'm going to go left to right. So 6 divided by 3 is 2, and you can even, if you want to still go step by step, then you just do that one first. If you want to go ahead and, well, I'm just going to do that. Divide by 2 times 4 still. And now I'm going to do my multiplications. 8 minus 2 plus 16. Okay. So I did my multiplications. I didn't do the subtraction or addition yet. Now I'm left with just subtraction and addition. Yes, the subtraction is before the addition left to right, so that means I go left to right. They're a tie. Okay, so that means I go left to right. 8 minus 2 is 6, plus 16 is 22. And that is my answer for that one. Okay? All right, let me put a parentheses in here and show you what that looks like. So this is an example of that. 8 plus, and then we got in parentheses 2 minus 6. Now, if that parentheses was not there, we would just go left to right. Because if that parentheses was not there, addition and subtraction is a tie, I would go 8 plus 2 is 10, minus 6 is 4. But the parentheses is there. That means we have to start with that. So in this case, the subtraction is going to be first. So 8 plus 2 minus negative 6, or 2 minus 6 is negative 4. Okay. And now this is why I've told you all of this mixes together, because now our, integers comes in. You got a positive, negative, you got a double sign. It never leaves us now. So if I have a double sign, I told you that later on in math, we were going to end up with double signs. We need to know what to do with them. So this double sign becomes 8 minus 4. Okay, the plus minus becomes minus, and 8 minus 4 is 4. Okay. All right. Let's do another parentheses, and this one I'm going to make a little bit longer in the parentheses and show you that you got to follow PEMDAS even inside the parentheses. Okay. Plus sign. Okay, so here's an example. I've got a parentheses, but now I've got some multiplication, division even going on, addition here. Okay, so we're going to start inside the parentheses. That's the first thing. We're going to start inside the parentheses. This will come later. And I'll show you when you're done with the parentheses, what it means when you're done, okay? So you've got the parentheses. Now, even in the parentheses, you got to follow order of operations. So inside the parentheses, I have to do the division before I do the subtraction. So I'm not going to do 5 minus 2 and do 3 divided by 2. That's going out of order. I'm going to do the division first. So inside here, I'm going to go 5 minus 2 divided by 2 is 1, okay? Or you could even look at this as negative 2 divided by 2 and got negative 1. But either way, you're going to get 5 minus 1, okay? So I did the division first. Okay, now this is what I meant about being out of the parentheses. We're not out of the parentheses yet, okay? So we need to keep working inside here. So 5 minus 1 is 4, okay? Now, this is the parentheses, and you say, well, does that mean then I need to add it to 6 because it's parentheses? We're done inside the parentheses. There's no more work to be done inside of the parentheses. So you can either take those off, or you can just remember, hey, this is done. I'm going to do multiplication before I do addition, okay? So we go 4 plus 18, okay? I did 6 times 3. And then all I'm left with is addition, and I get 22. Okay? And I know it seems like a lot, but I'm trying to give you all the different examples. That way you can go back and check each one and kind of get a hang of it and get the feel of this order of operations. Okay? Because there's all different kinds, just like integers, there was all different kinds of looks that I want to make sure we cover. Okay, so here's another one. So we've got, and I'll explain what these are called here in a second. Let me write the problem up there. And these I have to kind of do in advance because I want them to come out. We're not going to really be working with fractions. You will later in math, but we want these to come out even, meaning I'm not doing like 6 divided by 4 and having to do fractions in this case. So I have to kind of pre-think about them. So here's this problem here. Now I use this term, these are called brackets, but it's just another form of parentheses. This is why some teachers call it GMA. They don't even use the word P because they use G for grouping. Because as you get bigger into math, there's brackets and there's brackets on top of brackets and parentheses. But it's the same rule as that they're a grouping, they're a parentheses. We got to work with this first before we can do that. But also what it means is I've got a parentheses inside of another parentheses. So where do you start? This one's multiplication, but this is subtraction. So I mean, well, because you've got a parentheses inside a parentheses, this parentheses is one problem, but then inside of that is the first thing you got to start with is this parentheses. I always look at it like this. Start in your innermost parentheses and work your way out. So that means we're going to start with this, okay, and work our way out to the bigger one. So we're going to start with this. Okay, so I did 3 minus 2 and I got 1. We're done with that. There's nothing left to do inside there. Okay. And we still got all of this. But now, as you see, we got rid of one parenthesis. We're out of that one. Now we'll keep working out to the fuller one. And now I have addition and multiplication in that one. So I need to do the multiplication before I do addition. So in this case, I've got 1 plus 14. Okay, because I did 7 times 2. Now inside of there, I'm still not out of that. I still got work to do in there. I can add these together. But now I'm done. Okay, there's nothing left to do inside there. And so now all I'm left with is 15 minus 6 divided by 3. So I do division before I do subtraction. And so I got 15 minus 2. This is 6 divided by 3 is 2. And then 15 minus 2 is 13. Okay. I'll leave that up there for a second. Let me put a couple exponents in there as well because we need to cover what happens when you see an exponent. So here's an example of that. 5 squared times 3 plus 4. Now an exponent is just something times itself. Okay, it's not 5 times 2, otherwise they'd write 5 times 2. It's 5 times itself, so 5 times 5. So in this case, I'm looking here, there's no parentheses, but there is an exponent, okay? So I'm going to do that first before I do multiplication, division, or addition and subtraction. So 5 times itself is 25. Okay, 5 times 5 is 25. And then I have a multiplication and addition, so I'm going to do the multiplication first. So 25 times 3 is 75. And then 75 plus 4 is 79. That's what happens when you got an exponent. Well, what happens if you've got an exponent inside of a parenthesis? So now it looks like this. Well, we start with the parentheses first. Okay, we got to work inside there. But inside the parentheses, you also follow PEMDAS, which means you do an exponent before you do multiplication. So I've got to do this exponent. This is not 2 times 3. This is 2 times itself times itself. Okay, 2 times 2 times 2 is 8. 2 times 2 is 4, times 2 is 8. Okay, so this is 8 times 4. Okay, 2 times 2 times 2 is 8 times 4. And now I'm still in the parentheses, so I got to do 8 times 4, which is 32. And now I'm out of the parentheses. There's nothing left to do inside there. 32 minus 6 is 26. Okay, so I'm going to leave that one up there for a second and then put, well, yeah, I'm just going to leave this part of it so I have room and that you can see. This one started out where the exponent was in the parentheses. I want you to look at the difference between this one. Okay, this one's different because the exponent is outside of the parentheses. And we're still going to follow PEMDAS, which means I've got to do inside the parentheses before I can do the exponent. I did that here too, but it's inside the parentheses, so that's why I had to do the exponent. So here inside the parentheses, I'm going to do it first. So I'm going to do 5 minus 2, which is 3. Now I'm done in the parentheses, but I now need to do the exponent next. I need to cube that 3. 3 times 3 times 3, okay, which is 27. 3 times 3 is 9, times 3 again is 27. And now I can go left to right because all I have left is addition and subtraction. 27 plus 7 is 34. 34 minus 12 is 22. Okay. And I know that was a lot. Go back through and look at the differences. Look at, all they're doing, but basically always go through this step. Parentheses first, work your innermost out. Do all your work inside there till you're out of there. Even inside of parentheses like this one, follow order of operations. So do exponent before you do multiplication. Then you move on to exponents. Then these are a tie, and then these are a tie. These are last, but you do those last, okay? Let me put some practice problems up there for you. Get you started, and then we'll go through them on the next video, okay? Times there. That's an exponent. This is cubed. Okay? A little sample of all of them. Don't get freaked out on the big ones. Work your way through it. Start the innermost, work your way out, and go from there, okay? All right. Thanks, guys.